Romex, specifically NM-B cable, is generally not permitted in the upper floors above a commercial first floor in a mixed-use building. The National Electrical Code, specifically Article 300.15, addresses wiring methods and their permissible uses. This article restricts the use of Romex, which is a non-metallic sheet cable, in certain types of buildings, particularly commercial structures. The primary reason for this restriction stems from the inherent properties of Romex and the typical demands of a commercial environment. Romex is designed primarily for residential applications, where the conditions are generally less demanding than in commercial settings. Commercial buildings often have greater occupancy, high electrical loads, and more stringent fire safety requirements. The NEC mandates more robust wiring methods in these environments to ensure safety and reliability. The concern with using Romex in commercial settings lies in its vulnerability to physical damage. The non-metallic sheath is more susceptible to punctures, abrasions, and other forms of damage compared to metallic conduit or armored cable. In a commercial environment where there's higher foot traffic, equipment movement, and potential for alterations, the risk of damaging Romex increases significantly. Damaged wiring can lead to electrical hazards, including short circuits, ground faults, and even fires. Secondly, Romex does not offer the same level of fire protection as metallic conduit or cable. While Romex is typically flame retardant, it can still contribute to the spread of fire if exposed to high temperatures or direct flames. Metallic conduit, on the other hand, provides a fire-resistant barrier that can help contain a fire and prevent it from spreading rapidly. Thirdly, commercial buildings often have different voltage and current requirements compared to residential buildings. The electrical systems in commercial buildings are typically designed to handle higher loads and more complex equipment. Romex may not be rated for the higher current levels or the specific types of equipment used in commercial settings. The NEC requires that all electrical wiring be properly sized and rated for the intended application to prevent overheating and other electrical hazards. In new wood construction, additional considerations come into play. The NEC generally requires that electrical wiring be installed in metal conduit or other approved raceways to provide physical protection and fire resistance. This requirement is particularly important in wood frame buildings, where the wood structure can contribute to the spread of fire. Installing wiring in conduit helps to contain any electrical faults and prevent them from igniting the surrounding wood framing. The phrase "all fire ratings are observed" is not sufficient to override the NEC restrictions on Romex use in commercial buildings. While fire-rated Romex is available, it does not address the other concerns related to physical damage and suitability for commercial environments. The NEC is a comprehensive set of regulations that addresses all aspects of electrical safety, not just fire protection. Therefore, even if the Romex cable is fire-rated, it is still not permitted for use in the upper floors above the commercial first floor. It is important to note that the specific requirements of the NEC may vary depending on the local jurisdiction. Local building codes and ordinances may impose additional restrictions on wiring methods. It is always advisable to consult with a qualified electrical inspector or engineer to ensure compliance with all applicable codes and regulations. In summary, Romex is generally not allowed in the upper floors above a commercial first floor due to NEC restrictions, its vulnerability to physical damage, and its limited fire resistance. New wood construction typically requires wiring in metal conduit or other approved raceways. Observing fire ratings alone does not override these restrictions. Compliance with the NEC and local building codes is essential to ensure electrical safety. To further elaborate on the NEC requirements, it's beneficial to understand the different types of wiring methods recognized and approved by the code. These methods are categorized based on their construction, materials, and intended applications. Firstly, non-metallic sheet cable, commonly known as Romex, consists of two or more insulated conductors enclosed within a non-metallic outer sheath. It is primarily used for residential wiring and is available in various sizes and opacities. Secondly, metallic conduit includes rigid metal conduit, which is a heavy-walled, threaded conduit made of steel or aluminum. It provides excellent physical protection and is suitable for both indoor and outdoor applications. Intermediate metal conduit, or IMC, is a thinner wall version of rigid metal conduit. It offers similar protection but is lighter in weight and easier to work with. Electrical metallic tubing, or EMT, is a thin-walled, unthreaded conduit made of steel or aluminum. It is commonly used for indoor wiring in both residential and commercial buildings. Flexible metal conduit is a flexible, hollow conduit made of steel or aluminum. It is used for connecting equipment that requires movement or vibration. Thirdly, armored cable, also known as BX cable, consists of insulated conductors wrapped into flexible metal armor. It provides physical protection and is suitable for both residential and commercial applications. Fourthly, cable trays are open support systems used to carry large quantities of cables. They are commonly used in industrial and commercial buildings for power distribution, control wiring, and communication cables. The NEC specifies the allowable uses for each type of wiring method. Some wiring methods are permitted in all types of buildings, while others are restricted to specific applications. For example, rigid metal conduit is generally permitted in all types of buildings, while Romex is typically restricted to residential buildings. The NEC also provides detailed requirements for the installation of each type of wiring method. These requirements cover topics such as support spacing, bending radii, and termination methods. It is important to follow these requirements carefully to ensure a safe and reliable electrical installation. In addition to the NEC requirements, local built-in codes may impose additional restrictions on wiring methods. These restrictions may vary depending on the local jurisdiction. It is always advisable to consult with a qualified electrical inspector or engineer to determine the specific requirements for a particular project. The NEC also addresses the issue of fire stopping. Fire stopping is the practice of sealing openings in walls and floors to prevent the spread of fire. The NEC requires that all openings for electrical wiring be properly fire stopped to maintain the integrity of fire-rated walls and floors. Fire-stopping materials must be approved for use in electrical applications and must be installed according to the manufacturer's instructions. A proper fire stopping can compromise the fire resistance of a building and increase the risk of fire spread. Furthermore, the NEC provides guidelines for wiring in hazardous locations. Hazardous locations are areas where flammable gases, vapors, or dust may be present. The NEC classifies hazardous locations based on the type of hazard and the likelihood of its occurrence. Wiring in hazardous locations must be installed using approved methods and materials to prevent ignition of the hazardous substances. These methods typically involve the use of explosion-proof conduit, fittings, and equipment. The NEC also addresses the issue of grounding and bonding. Grounding is the process of connecting electrical equipment to the earth to provide a path for fault current. Bonding is the process of connecting metal parts of an electrical system together to create a low-impedance path for fault current. Proper grounding and bonding are essential for electrical safety. They help to prevent electrical shock and reduce the risk of fire. The NEC provides detailed requirements for grounding and bonding, including the size and type of grounding conductors, the methods of connecting to ground, and the bonding of metal enclosures. In addition to the technical requirements, the NEC also emphasizes the importance of qualified personnel. The NEC requires that all electrical work be performed by qualified electricians who are trained and experienced in the installation and maintenance of electrical systems. Unqualified individuals should not attempt to perform electrical work, as this can lead to serious injury or death. The NEC is a constantly evolving document. It is updated every 3 years to reflect changes in technology and industry practices. It is important to stay up to date in the latest edition of the NEC to ensure compliance with current regulations. The NEC is a complex and comprehensive document. It is not intended to be a substitute for professional judgment or expertise. It is always advisable to consult with a qualified electrical inspector or engineer for assistance with specific electrical projects. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with the qualified professional for specific guidance on electrical installations and compliance with the National Electrical Code. In summary, understanding the nuances of the NEC and its specific requirements for different wiring methods, building types, and environmental conditions is crucial for ensuring electrical safety and code compliance. The restrictions on Romex in commercial settings are in place for valid reasons, and alternative wiring methods should be employed to meet the demands of these environments. It is essential to prioritize safety and consult with qualified professionals to ensure all electrical installations are performed correctly and in accordance with the applicable codes and regulations. Therefore, it is clear that Romex is typically disallowed on upper floors above a commercial first floor due to the National Electrical Code and other safety concerns.